Hello everybody and welcome. Just give me 1 second while I flick over to the presentation and I think we are all good. Fantastic. Thanks for joining. This is Accessing Your Creative Desktop Estate Remotely. I am your host. I'm James Dancer. I'm Academia Technical Director. And this is going to be an interesting one because this topic is really hot topic at the moment, actually. There are so many conversations going on between ourselves and with customers about how they literally access their creative desktop estate remotely. The thing to bear in mind is this is for any kind of use case. It doesn't necessarily need to be creative, but creative for obvious reasons is certainly the most popular scenario we're finding for customers wanting to access lab machines outside the environment, which is, yeah, something that we absolutely want to help with. So, moving on swiftly, we've got a few different topics to cover today. So I'll be covering a technology called NoMachine with you guys. And then we have Matt from HP talking about ZCentral. And then we have Karen from Leostream talking about Leostream, which is kind of the glue that holds all of this stuff together. So these are three solutions that work absolutely perfectly together. And we're seeing a lot of positive response to this as we're talking to customers and deploying stuff throughout this period. Actually, just very quickly, just because I want to make sure audio is working okay. Matt, could you just do a quick mic check and say hi for me, please?
Yep. Hi, everyone.
Excellent. There we go. And Karen?
Hey, this is Karen from Leostream.
Hey, right. Okay, cool. So we can move on then. So bit of housekeeping. Just quickly, I know a few of you have made use of the chat already, which is great to see. Please feel free to use chat as much as you like. This is ideally a collaborative session if we can make it one. If you want to ask a question to the presenters, just above where you would type your comments in the chat box on the top right, there's a little bubble that will currently say chat mode next to it. If you want to ask a question, click that and that will change to Q&A mode. And what that basically does is when you send a chat message, it puts a little red Q bubble next to your chat message so it draws our attention to it. Perfect. There we go. There's one already. So if you forget to do that for whatever reason and you've posted a chat, the bubble is still there, so you can click it and retrospectively turn it into a question. And if you forget how to do all of that, we have Karis from our marketing team in chat moderation today, who will be able to notice any questions that haven't been picked up and convert them to questions for you. When we're answering stuff in the Q&A section at the end, we will demark them as questions. So if you notice that bubble disappear, please don't remark it as a question if we've asked it. Otherwise, it will get a little bit confusing for us. Final thing to mention is there is around a 10-second delay between the presenters and the live stream. The reason for that is if we have to kill the feed or reload the room for whatever reason, that gives us a little buffer of time to do it. So it does mean that real-time chat can get a little bit awkward. So if you're asking a question, please sort of give us as much information in that question as you can, because otherwise there'll be ultimately a 20-second round-trip delay before we can interact properly. So those are the only things to mention really from a housekeeping perspective. Please ask questions all throughout the session and we'll address them at the end. And we're allowing a good chunk of time for that because we're expecting quite a few of them. So without further ado, into NoMachine. So NoMachine is in this context is a piece of software that sits on your endpoint target devices. And for the avoidance of doubt, these are the devices that are sitting in your labs that you want to provide access to remotely. It's a piece of software that sits there and provides a dedicated remote desktop protocol that a piece of software like Leostream, for example, can then broker for remote connection. So it's there's not much of a demo or anything graphic to do here because it literally is a protocol that sits on an endpoint. But there is support from NoMachine for Windows, macOS, and Linux. And as you'll find out from Matt in a little bit, HP ZCentral also supports Windows and Linux, so the correct use of the correct tool for your environment is a really important thing to get right. But certainly we're finding NoMachine is the most popular in the macOS environment, with a little bit of Linux as well. But usually the correct tool for the job when we're talking about the best possible product mix is ZCentral for the Windows side, NoMachine for macOS, and then Linux is kind of dealer's choice depending on how your environment works. So in terms of key features, so NoMachine is very, very good at keeping audio and video in sync. So the reason we recommend this for creative use is it runs its own proprietary protocol called the NX protocol. And that was built with the ability to keep audio and video sync in mind when you're accessing a workstation remotely. So as we know, that's really, really important. And if you're using protocols like RDP or VNC, a lot of the time that doesn't really happen. So this is why we started engaging NoMachine originally, was to, when we'd managed to find a product that had that sync capability and worked as if you were in front of a creative workstation. So the sync element is a really, really key feature there. It also features H.264 hardware encoding and decoding, which, as anybody in creative will know, is a really, really efficient codec. So we like the fact it uses H.264 and it's compatible with a load of different systems and environments. And it also supports file sharing, USB forwarding, which is a really interesting one. So if you have peripherals that your students might want to use remotely, you can forward that USB connection to the host or the target machine that's inside your environment. Big caveat there is that your mileage may or will vary on the basis of bandwidth. So it's important to test first, but the protocol does support USB forwarding, as well as things like printer mapping. Screen sharing is a really, really useful one because it allows you to effectively have someone virtually looking over your shoulder at your screen, and that's a feature that Leostream supports internally as well. So you can have someone working on a workstation and they can say, actually, I'd like someone to take a look at what I'm doing, dispatch a sharing link, that person can jump on and have a look too, which is really nice. And the bit that I'm going to focus on a little bit, because we always get questions about this, is the fact that it has extremely granular control over the local device, i.e. the one sitting in the lab, and how that behaves when someone is remotely connected to it. So the way that works is, yay, config files. Everybody loves a config file. So I'm not going to labor this point because we've got a lot to get through. But there are a couple of different config files you would configure in a NoMachine environment, and these sit alongside the NoMachine Enterprise Desktop app itself. So depending on the platform, with Mac OS, it's bundled into the application package as two files that sit within there. Within Windows, they're in an install location, and the same thing as Linux. So depending on how you're managing your devices, you can effectively get a template of those two files and then push them out to each device that's on the network, so they all behave in the same way. So for Windows, you may use Intune or SCCM or something like that. For Mac OS, you'd use MDM. There's a number of different MDMs. And for Linux, if you use something like Spacewalk or Rudder or any various Linux management pieces of software, all you have to be able to do is inject two text-based config files into a specific location on each of the devices, and they will all behave either exactly the same or differently in groups, depending on how you've configured the config files. So how this works is there are two different files, and I just want to get the terminology straight because this kind of scenario is sometimes a little bit backwards based on terminology. So when I'm referring to node, that refers to the machine that will be used as a remote target, i.e. that device that is sitting in the lab that was running all your creative software. It's a big, powerful machine that you want students to be able to access outside the network. So that's the node controls and configs affect that physical machine, as in it is an OS, it is a physical machine. And when I'm saying server in this specific context, it's referring to the underlying server process on NoMachine Desktop, i.e. the thing that is providing that remote desktop protocol-based service. So even though it's not a server that sits in an infrastructure and is a blade in a rack or anything, it is a server process. So I just wanted to make sure that that terminology was straight. So you have two of these config files that sit behind NoMachine. First one I'm going to go through just very briefly is server.config. That's the general behavior of the server. That kind of defines things like enabling, disabling, local confirmation being required to remotely connect. You obviously don't want that to happen in a remote scenario because the user isn't anywhere near the machine. So you can choose that isn't the case. And you can choose whether users can access that machine with admin privileges or not, regardless of what their account privileges are. And if there's a multi-node environment, which isn't so relevant to this context, but you can choose things like load balancing algorithms. And the one we get asked for or asked about most of the time is the fact that you can choose that when a remote user connects to that target device, the screen can be blanked and the remote and the local, keyboard and mouse can be disabled. So obviously what you don't want to happen in this environment is someone connected to a remote session and people being able to see what they're doing on the screen and potentially using the local keyboard and mouse. And that's obviously not a particularly great scenario to be in. So server.config allows you to control things along those lines. So the note I've got at the bottom there is any settings in server.config applies to all users that connect regardless, and they're overridden by profile rules when a profile rule happens to be set. So it kind of sits in the middle part of the hierarchy in terms of controlling what the protocol does. Onto Node. So Node is behavior specific. So that's about how the node itself works. So, for example, enabling, disabling services. So whether you can share devices, printers, and enact file transfer with that target device. Whether you want the NoMachine icon in the system tray, because sometimes you don't want the users to be able to either know what they're using or to be able to click on the icon and try and change settings and things. You can also enable and disable server preferences if you want, as Node sits atop the server config, and you can do things like setting an inactivity timeout for logins, which is something that Leostream can handle as well. So depending on how you want to set up the environment, you've got a number of different options. But ultimately, when we get to the Leostream side of things, it will obey whatever it is that you're doing in these config files. These relate to that device that is sitting in the lab, and Leostream will provide a connection to it. So the note about node.config is settings in this file applies to all users accessing the host, and they're strictly dependent on that host environment. So that node, that target device, that machine sitting in the lab. So I've got a couple of examples of how this looks, and don't be scared. I know they're text-based config files, but they are extremely, extremely descriptive. So, for example, in server.config, this is exactly what the config file looks like. This is a copy-paste straight out of that file. It gives you a full description of exactly what this stuff does, provided you remove the hash at the start of the setting. So at the bottom there, you can see enable screen blanking. If there's a 1 after it, it's enabled. If there's a 0 after it, it's disabled. Pretty straightforward. So all you need to do to kind of hone in on your remote target environment is literally read through the config files in plain English, remove a hash, and add a 1 or a 0 next to the stuff you either want to be enabled or disabled explicitly. So that's pretty straightforward. Node.config, similar kind of thing, but an example of what you can do in Node.config is parameter-based additions to specific options. So rather than just a 1 or a 0, if you can see it at the bottom there where it says display server extra options, you would remove the hash, and that basically says timeout after 300 seconds of inactivity. You can add a lot of these together in a string, but there's a lot more like flexible options that sit outside a straight config file in node.config. So I know I've gone through that in a bit of a whirlwind, but we've got, as I said, quite a lot to go through today. So I want to make sure we cover everything. If you've got any questions about this, please feel free to throw them at me in chat. We've got demo files you can look at. We've got demo installations for NoMachine. It's a pretty simple and straightforward thing to deploy once you've installed the application. You build your template config files, and then you deploy them with whatever your device management estate is or whatever your device management tooling is. So on that basis, I'm going to hand over to Matt to talk about ZCentral.
Great, thank you, James. Hi, everyone, and thanks to the academia team for setting this up. So by way of introduction, my name is Matthew Ireland. I'm a HP workstation specialist. I specifically work with our public sector customers, but also specialize in the AEC industry. So work with a number of the top architects, engineers, and construction companies in the UK. Today, I'm going to introduce you to ZCentral Remote Boost. Now, Remote Boost isn't a new product for HP by any means. It's something that we've had for about 10 years or so now, and we often refer to it as HP's best kept secret, because although it's widely used in M&E and the AEC sectors for remote workflows, there's still a lot of people that don't know about it. So it's previously known as RGS, Remote Graphics Software, if you were ever familiar with that product. But essentially what it allows us to do is to remote into our Windows or Linux-based desktop workstation through pretty much any device. We're providing a one-to-one connection between the endpoint and the host. And what we're really trying to achieve is that at-desk local experience, but be able to deliver that from anywhere. So Remote Boost, in simple terms, is just an application that is downloaded on the host workstation. an application that is downloaded on the endpoint, and then the two connect, allowing that endpoint to utilize the full performance of that host workstation. All we're doing is shifting pixels, so we're not shifting any data from the host to the endpoint. It's purely the pixels, which is great for a couple of reasons. At first, it's really secure because we're not sending any data across that connection. It's purely the pixels. And secondly, we can get really great frame rates. So typically we see up to and in excess of 60 frames per second in many applications all over variable networks. So the number one question that we normally get asked is, if a user at home has a pretty poor network, what's their experience going to be like? Well, we can guarantee that it's going to be pretty good, even if it's over a poor network, because we're moving such little bandwidth, just the pixels, and we can guarantee a really, really good performance, even over a pretty poor network. ZCentral Remote Boost allows at the endpoint for the user to have dual 4K display setup, so really, really good for productive working, and it allows us to address a number of certain customer needs. So obviously, first of all, remote working, really prevalent right now, is how do we get those users access to their desktop workstation, but it also allows us to give access to users only when needed. So you could quite easily within an organization have a user that only needs to dip in and out of CAD models. 80% of their time they're working within Office applications. We can give them a device that is capable for running those Office applications and then give them access to a remote session as and when they need it, so that we can share these pools of resources. Now, ZCentral Remote Boost allows us to build a solution around the user as opposed to building around the hardware or the data or the people, because we can enable them to access this performance from anywhere, as long as on the endpoint they are running Microsoft OS, Linux OS, or Mac OS X. They will be able to download a Remote Boost receiver license, which in turn will be able to connect to a Remote Boost sender. So that enables them to pretty much access through any device. So any brand, can be a laptop, tablet, thin client, all in one. The company's data is really secure as it remains on the hardware. The pixels are sent using 256-bit encryption. So that means that we can stay compliant with a number of rules such as GDPR and other compliancy rules, but also we can protect the customer's IP. We can block all or selected USB drive devices at the endpoint. So we can control, if, give access to a mouse via USB, but we won't give access to a USB stick because we don't want them to pull any data off. So you have that granular level of control of your data. We can do all of this whilst maintaining really good performance. So like I said, high frame rate, like local experience, but also we're maintaining our workstation's ISV certification because all of the work is being done on the host. The software sits there, all of the computational and graphical work is done there, so it maintains that ISV certification. Now within Remote Boost, there is a great tool called Collaboration Mode. So as I mentioned, we are one-to-one from host to endpoint, but we can actually get 10 remote users on that one session. So really, really useful. For example, if you have teams of people working with an organization on a specific project, they can all jump on that one remote session and start working on their CAD model, for example. Only one person can drive the mouse at any one time, but if my colleague wanted to make an amendment to a CAD model, I could pass them access to the mouse, they could make that amendment and then pass it back to me. So really useful from an organizational collaborative working point of view, but also see big use case for this in higher education space, because you could have subject lead running the session and then have a number of users on that session as well. They could teach from it and or do reviews from it. So really, really useful from a collaborative point of view. A couple of new features that we've introduced in the new naming convention of Remote Boost. We used to have an issue within RGS with image scaling, so locally resizing the remote desktop when we're jumping between resolutions. So if the host was running a 4K application, but in the end user's home, we only had an HD display, whether it be a laptop or a monitor, we had real issues with resizing the remote display when jumping between those different resolutions. That's now fixed, so we can now jump between resolutions and not have that issue. We've also added in support for Ubuntu, so great for anyone who wants to do remote access for things like machine learning or data science. We now have that level of support there as well. So if you had any issues from an operating system point of view, HP would support you with that as well. This is really how we see ZCentral working in a centralized workstation workflow. So rack mounting our workstations and then having that as a central pool, and then using Remote Boost as the application to remote into them. But we're finding specifically in the higher education spaces, customers are simply just leaving their workstations where they are in situ on the desk and then using Remote Boost as the application or the go-between. So there's not necessarily a driver to absolutely centralize all of your workstations, but that's generally why we're positioning it, where we're positioning it, and we're releasing a number of rack-based workstation products over the next year or so, which kind of go in line with that. Now, this is how we compare up to what we traditionally call our competition, which would be an EVDI solution. With this, ZCentral Remote Boost in the middle there, all we're doing is providing a portal to access the full power of that workstation. So we're delivering that local experience. As opposed to, on the EVDI solution, we're taking that host workstation and we're carving up the resources. We're paying additional fees for extra VM licenses. We're paying NVIDIA grid cost licenses in that scenario and delivering inconsistent performance to our users. So generally, from our point of view, ZCentral Remote Boost is a far more cost-effective solution, and we can guarantee that level of performance. Now, finally, for me, it's how we license it. So ZCentral Remote Boost is actually free on all HP Z workstations. So if you have any HP workstations, you're actually already licensed. Typically, you'll find that most users blow it away in their image, but you can re-download it. The license key just sits in the BIOS, and you basically re-download it, and you're good to go. It is a paid-for license on non-Z workstations. The only operating system we don't support is Mac. So this is pretty much for any brand with the exception of Apple. There are two options from a licensing point of view. We have floating, which means we can move that license around amongst different workstations, or we have perpetual, which is essentially tied to the machine. Now we're licensing the machine, not the user. So if you have 50 workstations with 50 Remote Boost licenses, there's no limit to how many different users can access those workstations. So only 50 would be able to access concurrently because it's a one-to-one connection, but we could have 300 students that all have access at different times. So we're not adding any additional charge for the number of users that use it. It's a one-off payment. So just one-off payment, you own it. There's an optional yearly support contract, which you're not necessarily obliged to take. So it could just be a one-off cost. And as outlined on this slide here, we currently have it on a free 90-day trial. So something you can download and use for the next 3 months free of charge, and trial it within your environment. Obviously, the next question is, how do we broker this, or how do we manage the remote connections, which I think will lead quite nicely on to Karen's piece on Leostream. So thank you very much. Obviously, if there's any questions at the end, we'll answer those, but I shall pass over to Karen. Thank you.
Great, thanks very much. I'm really excited to join you here today, and thank you, Academia, for inviting Leostream to participate. For those of you unfamiliar with Leostream, just very briefly, our mission for the last 18 years has been to build the premier remote access platform for hosted desktops. And what makes Leostream unique in this is our philosophy on remaining vendor neutral to the rest of the hosted desktop environment. We allow you to determine what sort of resources users need access to, what sort of client devices the users can have, and what display protocol can be used to connect those two endpoints, so both NoMachine and ZCentral. But more importantly, Leostream gives you the ability to build business continuity rules that ensure your remote access solution meets your business needs or your university's needs, really no matter what those needs may be. Now that's well and good, but let's dig into a little more detail and show how this really does apply to your specific needs. Now, I'm guessing some of you are thinking, I've never heard of this Leostream company before. So why exactly does someone use Leostream as their remote access platform? Well, for the various reasons you see right here. Beyond the rather generic, it's easy to install and provides remote access from anywhere tenants, there are really two reasons companies turn to Leostream. You either have something in your environment, be that a remote guest operating system like macOS, or maybe an MFA provider, that no other solution integrates with, or you need to do something in your environment, maybe balancing an on-campus and off-campus student base, that no other solution allows you to do as effectively. To break those two aspects down a little more, let's start with what you have. Leostream's vendor-neutral approach to the remote side means you can simultaneously manage connections to all the physical machines in your lab, but also if you do have virtual machines, maybe they're vGPU-enabled machines, or if you want to actually look about bursting up into the cloud and take advantage of some of the GPU capabilities up in the cloud, you can do that with Leostream. And these can be running any operating system, Windows, Linux, Mac OS. It really is transparent from a Leostream point of view. So that means pretty much you can provide users with a single access point to everything that they need to get their work done. And you can authenticate users into those systems using the authentication methods you use today. Leostream supports a number of different authentication systems. We see a lot of Active Directory, OpenLDAP, but we also allow for multi-factor authentication using names like Duo and Okta and various others. That means you can actually model some really fancy maneuvers in Leostream, like requiring students who are remote to pass through an MFA, second factor of authentication, while not requiring students who might be logging out on campus from doing the same. So that was a little bit about talking about what you have. On the other side, when it comes to what you want to do, that's where Leostream's 18 years of really honing our pooling and policy logic helps you model all the different workflows in your environment. From sharing a classroom of machines with on and off campus students to maximizing the utilization of a group of lab machines, or as I mentioned, maybe even bursting students into the cloud if the lab is full. And the thing is, Leostream doesn't just enforce these workflows, it also tracks the users who move through them. Leostream's logging capabilities mean you always know who is using what, from where, and for how long, which we see becoming increasingly important as the student base scatters. So let's break this down to a real world example. First, let's get you grounded in the components that make up the Leostream remote access platform. At a high level, it consists of 4 components. Starting at the top right is the connection broker. It's essentially the brains of the operation. It's where you'll define your pools and the rules to assign users and students to them. On your hosted desktops then, your Macs, your Linux, your Windows machines that you need to connect users to, you install our Leostream agent. Now the agent is a small component, but it's essential for you to get the most out of your Leostream environment. It's the component that's doing the tracking I mentioned on the last slide, and it sends that information back to your connection broker so you can automate actions based on those events. So those 2 components, the connection broker and Leostream agents, are deployed in your campus or in your data center, basically wherever your hosted desktops live, maybe in your labs. On-campus users then can log directly into the connection broker, or they can even log directly into the desktops. I'm going to sit down at the lab desk and just log on in, and Leostream can still manage that user's desktop session. But now what happens for all the students who are leaving campus? That's where the third component, the Leostream gateway, comes into play, sitting in the middle there. The Leostream gateway has 2 purposes. First, it's a conduit for remote students to log into your on-campus Leostream connection broker environment. That's the login step that you kind of see near the top right. Off-campus students point their client at the publicly facing address of Leostream gateway, and the gateway sends the login traffic to the connection broker. After the connection broker works its magic to authenticate the user and determine what are the correct resources to offer them, the Leostream gateway switches gears and acts as a tunnel for the user's connection to their hosted desktop. And this works just great for NoMachine and the remote boost. So now the Leostream gateway essentially eliminates the need for you to provide the students with a VPN connection to access your on-campus desktops. And that can be beneficial for a couple reasons. First, if you don't already have a VPN to support remote students, you don't need to acquire and configure one. And then second, we have seen that VPNs can be a bottleneck on desktop connection performance. And since our Leostream gateway functions as a simple port forwarding system, it doesn't introduce the performance hit that can come from an overloaded VPN. The final component in the Leostream platform is the user themselves, or more specifically, the client device they sit down at. Leostream does support a wide range of client devices, any Windows, Linux or Mac device is just fine, different than clients, even a Chromebook if you want. Pretty much anything your students may have. Okay, so now that you know the components that make up our solution, let's look at a real world example of how you can use them. So right now, many of you are faced with the question of how do you service an on-campus and off-campus student population? Well, here's how Leostream can help you and help you to ensure that the off-campus students can get access to the resources they need while still allowing on-campus students to work uninterrupted. So to begin, you define pools of machines to offer to different types of students in Leostream. Maybe the pools are based on class, maybe it's based on application, the actual physical lab room they're in. Pooling in Leostream is very flexible, so you can model your pools in whatever way works best for you. After you have your pools, you build Leostream policies to offer students machines from the correct pools based on their needs, and you build protocol plans that tell Leostream how to connect students to the desktops in those pools. So maybe you want to connect users using NoMachine to the Macs, but you want to connect them using ZCentral to your ZCentral workstations. All of that works within Leostream, and you can mix and match and pick the right resource and the right protocol for the right student. And the nice thing is, all of the features like collaboration and USB pass-through that have been mentioned during this presentation, all of those work seamlessly when the connection is launched using Leostream. Okay, now as users start to log in, Leostream recognizes using rules you define which students are on campus and which are off, and make sure to avoid conflicts. So off-campus users are guaranteed a free machine that doesn't conflict with anything an on-campus user is using. Leostream also knows how to direct off-campus student connections through the Leostream gateway while connecting on-campus students directly to their machine. So it kind of optimizes your systems. So that's all great from the student side. Now let's talk about what benefits Leostream brings for IT and instructors. Leostream's role-based administration allows you to build special roles for instructors or IT staff for interacting with the Leostream environment itself. So for example, you can build a role that allows instructors to view and manage a particular pool of desktops. And maybe that's the pool of desktop for their class. So now they can actually look at that pool and see what students are connected and logged in, almost like they're taking a virtual roll call. You can also use the information provided by the Leostream agent to automate the length of time a student is allowed to use a particular resource. Just think about a student whose desktop session has been idle for 30 minutes. And by that, I mean no keyboard and mouse movement. If you want to make, you saw how there's the config file where you can set an idle time setting in there. But if you want to change that length of time based on student, you can use the Leostream agent to monitor idle and then set different actions to occur when that idle time happens. So maybe you want to just log the user out after they've been basically asleep for 30 minutes. As another example, maybe you want to allow lab machines to be used for up to 4 hours. And after that, the student has to make the machine available for someone else. Leostream can automate those rules for you as well. And those are just some of the examples of the things that you can do in Leostream. Oh, this slide's supposed to be progressive, but that doesn't seem to work in this platform. So I'll just slip to here. So typically I would do demos during webinars, just because I really find that showing the interface from the administrator point of view for Leostream can be a really powerful way to see the different functionality and the flexibility that you have. I don't really have time for a demo, so let me just kind of step you through some of the diagrams that model the scenario I just described. So if you look on the left, that is a little shot of the Leostream administrator web interface, essentially little menus down the left here. And in that configuration section that's highlighted, here's where you're going to define all of the workflows that manage remote access to your different machines. And what you're seeing there is how I've pooled machines. So in this case, and this is my demo environment, I created pools based on classes like Math 202. But then I also created a lab, the cloud lab there, which is actually connected to Google Cloud Platform. So I can burst some people up into the cloud. The key in the pools is build them however is going to work based on what you need to offer out to the users. And then what you do is you use Leostream policies to actually offer those pools out to users and tell Leostream how to manage the session, such as which protocol to use. So in my environment, what I did is I assigned policies, a student policy, to anybody who was in a particular Active Directory group. And that's pretty typical what we see. People use group membership in AD to assign a policy, a Leostream policy out to a student. And then what I've done further in the form that you see on the top right here is inside the policy, I've said, well, who really does have access to the math pool? In this case, I'm saying it's only people who are a member of the math class, which I've done, again, by using Active Directory groups. And using groups is just an example. There are various different ways that you can do this assignment. So those two figures that you see at the top, that's little snapshots of the administrator web interface, all done through the web, very easy. On the bottom right is what happens when a student logs in. And in this case, they happen to be logging in using the web client. But we do have a Leostream Connect client that's a software client you can install. Both the web client and the Leostream Connect client can launch NoMachine as well as the remote boost connections. So here on the bottom, you see that this is a user who happened to be a member of two different classes. And so they see the pools that they have access to, and then they can decide, okay, what class am I working on? This is the one that I need to actually connect to. Okay, just to wrap things up, hopefully that motivates you to look a little bit more at how Leostream can help you with your remote student population or any other remote access problem that you might need to solve. The thing that we always tell our customers, with our vendor neutral approach, we can help you solve the problem that you have today, but what it also allows you to do is future-proof your environment for later. Use what you have now to solve the problem at hand, but always think about how you can build an environment that takes you forward. And Leostream can really help you do that, so you can invest in now and also in your future. And with that, I'm just going to hand it back over.
Thank you very much. Right. Okay. Wow, that was active in terms of questions. Thanks very much, guys, for going through both of those presentations. That was awesome. So yeah, I guess we've got to hit some questions then in that case. I'm going to skip around a little bit just because I think it might be better for context. So normally I'd go earliest to latest questions, but I just want to address one in particular that says, so are you saying on the desktop we install NoMachine Enterprise Desktop, also Leostream Agent, and then run the connection, broker, and gateway? And yeah, that is exactly right. So effectively, we probably should have put a workflow, or I should have probably put a workflow diagram together for this. But if you think about the target devices that are in your labs that you want to access, those can be NoMachine, they can be ZCentral. To be fair, you can even use VNC or RDP if you're absolutely sadistic, but you can do that as well. And the Leostream agent then gives you some additional parameters that you can gather from those machines about user logged in state, and as Karen said, some things about idle time and stuff. That all then connects to the Leostream broker, which then means that when a student accesses it, they can choose any of those protocols and any of those different machines to access, dependent on the rules you set that Karen just showed you in the presentation. So that's kind of the thing we're going with here. And I want to dive absolutely right into I know it's probably an awkward thing to answer considering the presenters, and then we'll cover that one off as well. Not awkward in any way whatsoever. It said to be useful to understand specifically that is Leostream allows you what Leostream allows you to do that NoMachine Cloud Server doesn't. So number one, use a GUI. That's quite a big thing for some people. Everything is configured in a web browser with a nice friendly interface, as opposed to CLI. And don't get me wrong, I love CLI as much as the next guy, and I could ramble on about Linux-based stuff for ages. But the point is, especially in education, you might have lots of different people with lots of different skill sets that want to manage the broker environment. So that's why we've engaged Leostream. Is that one? It's a multi-protocol. So it supports not just NoMachine, but a bunch of other different protocols, as you've seen. But also it allows really, really easy access to be able to manage pools, resources, etc. And there's some other really cool features as well, like multiple active directories. That's like multiple AD support's kind of cool as well. And that's native. That's not having to install anything on the back end like NoMachine Cloud Server. That being said, Cloud Server does have a place, but it's more if you are locked into the NoMachine environment specifically. What we're kind of finding, and what we've certainly found over the last few months, is that the access to lab machines has grown into a bigger conversation. Like, it started as right, there's a load of students working or learning remotely. how do we provide access to machines they would normally access in a lab? So that's how this whole explosion of these conversations started for us. But actually what that's turning into now is people are having sort of thought processes of, this is awesome for blended learning, because normally a lab would shut at X time in the evening, depending on whatever's happened. And at that point, the access for those students to learn on those types of devices with that specific software and that specific power is cut off. Using this kind of environment means that a student can effectively jump on a lab device at any time of day, any day of the week, and carry on doing their coursework, carry on learning, and carry on engaging. But it's on their time. There's such a big blended learning discussion going on at the moment that this has now turned into a bigger discussion than how do I fill a gap. It's actually I can enhance the way my organization delivers teaching and learning, which is an absolute huge point. And as a result of that, that expands out from how do I access my Mac estate remotely, which is, to be honest, how it started for us, to I want to throw Windows machines into the mix, I want to throw Linux machines into the mix. And that's why this whole suite of products that we've been talking about today works perfectly together. So Leostream's the glue that binds it all together and then allows that remote access. And then from a protocol perspective, NoMachine is absolutely awesome for Mac OS and a bit of Linux as well. And ZCentral is absolutely amazing from a Windows perspective. So that's why we've chosen these product suites to talk to you about today. So hopefully that sets a bit of context. So let's have a look at what we got question-wise. So there's a couple of questions specifically about deploying configurations with Jamf. So I'm going to say that first one that came in that says, what's the best way to deploy configuration profile via Jamf to allow accessibility for NoMachine, as we have tried during this trial and it does not work at all. If you could, you'll have an email from, or my email address from the reminders for this webinar. If the person asked that, if you could just ping me an email afterwards, that we can engage in a conversation, because I'm assuming that's a question that's around PPPC, which is a really long thing to get into in a Q&A section of a webinar. So if you could engage me afterwards, I'll either chat to you myself, I'll engage our consultants internally, and we can have a chat from there. And the follow-on from that was, what permissions should the node.config or server.config have when deploying via Jamf? If possible, templates or demo files would be good to have, as mentioned. Absolutely, I can send you demo config files of both. That's not a problem. We've generated some specifically for that purpose. In terms of permissions, they only need to be read by the launched application. They don't need any special permissions. They're not changed or edited by the application. They only need to be read at the point where NoMachine Enterprise Desktop launches, and that kind of sets its state for the session. So, apologies for kind of breezing over those a little bit, but I could absolutely go down a massive rabbit hole with those. So please email me afterwards, and we'll engage certainly with that. I'm going from bottom to top, so there's a lot of NoMachine heavy stuff. Apologies, guys, for the moment. I'd be keen to know more about NoMachine file transfer. Maybe I didn't read it correctly, but does it allow transfer of files between home client and the node? That's exactly what it does. So you have a local file section, a remote file section, and you can transfer files to and from those environments. The thing that I would say to bear in mind is you are transferring organizational data outside of the organization, that scenario, because there's the potential for the students to use their personal devices. So just be a bit careful about what sections of your infrastructure you allow that file transfer to occur within, because that is a really, really easy way to extract data. That depends entirely on your data security posture, though, so I can't advise you on that. But in terms of what the feature does, yeah, it allows remote file transfer between the person who is remotely accessing a device and the remote device itself. So if you're able within this webinar to demo the student POV experience, so yeah, we'd love to, but we're on quite a tight timescale. But if there's enough interest, and please feel free to feedback, probably to Neil, because I'm assuming most of you guys know Neil if you're in this webinar. We're happy to organize a further session. We can do a workshop-y, demo-y session if that's something you want to have a look at as well. Unfortunately, we're just under a bit of time pressure in this this specific webinar. I thought this was a NoMachine webinar. How come we're hearing about ZCentral? Am I missing something? So no, this was about remote access in general. So the initial journey really, when we started doing remote access webinars, started with NoMachine, but it's certainly expanded out into accessing PC estates remotely and Windows-based estates. Hence, getting the chat about ZCentral. Okay, so that's, I think, the NoMachine specific ones. Matt, there's one for you now, mate. Does ZCentral support PC audio to client?
Yep, nice and simple. Yes, it does.
There we go. That was the quickest one in the world.
Easy.
Amazing. Thank you very much for that. Where are we? I've found the NoMachine Cloud server providing unreliable results. Is there a way to improve this, as I only need access to Max and all of the other scenarios are in hand, and the advantages I see offered by Leostream do not any value for my needs? Okay, well, in that environment, there is a bit of a your mileage may vary, because I'm assuming the unreliable results are quality and latency and things like that. So there's, regardless of the server service you are using, there is a protocol discussion there. So bear in mind, Leostream uses the same protocol for that remote access, that NX NoMachine protocol, as NoMachine does. And so it's going to be down to how efficient that works over your network, based on the reliability side of things. The thing I will say, though, is the way that the Leostream broker works with the gateway for remote access is far more efficient than NoMachine Cloud Server. And I'm not in any way like trying to trash NoMachine. We're an advocate of that product, absolutely. But it's made for, the cloud server is made for a very specific environment, whereas Leostream is insanely efficient when it comes to remote accessing that particular protocol and a number of other protocols. So what we'd say is just like have a trial. We can sort out trial keys and things for you. The installation of Leostream is really, really simple. Like I personally went from having not used Leostream before to deploying a test environment with endpoints and having read all the manuals in about an hour. So it's not a huge install process by any means. But if you're noticing that the efficiency isn't quite there with NoMachine Cloud Server, absolutely give Leostream a try, because it might act more efficiently in your particular environment. Again, huge caveat of your mileage may vary there, because I don't know your network environment, but it's certainly something to give a try to. Can these products allow a video editor to move their footage to the remote access machine to allow editing? So from a NoMachine side, absolutely, file transfer. Matt, I don't know if you want to weigh in here at all.
Yeah, absolutely, from a ZCentral point of view as well. No problem.
It's so quick now, aren't they? That's great. One thing it might be worth going through, actually, because I've noticed a couple of questions around this, Karen, is maybe a little bit more of an explanation into the Leostream agent and what that provides specifically. Is it okay to sort of do a little bit on that for me?
Yeah, I'm happy to do that. So the Leostream agent, there's two versions. There's a version that does require Java, and that's the version that installs on the Mac OS and on Linux. And then there's also a native Windows service for installing on whatever kind of Windows operating system you might be using. Now, what the agent's doing is it's monitoring the user session. And it's the desktop connection session. We're not looking to see what applications they're using or anything like that. It's looking to see who logged in, did they disconnect, did they reconnect, have they gone idle? And it's sending those events over to the connection broker. And it does that regardless of how the user logged into the machine. So they could have logged in remotely using ZCentral Remote View Boost. Maybe they logged in using NoMachine. Maybe they sat down at the console. All of that information goes over to the connection broker. And then in what we call release plans and power control plans, you can use those events to automate actions. So I mentioned logging the user out if they're idle for 30 minutes, but you can also reboot a machine when the user logs out, or give them 30 minutes after they disconnect before they log back in. So really the agent is a small little service that's monitoring for these events, and then it's based on those events that the broker gives you the power of really kind of optimizing and maximizing the usage of your different devices.
Awesome, thank you very much for that. And yeah, I think it's just worth mentioning that the actual deployment of the agent is pretty straightforward as well. There's from a Mac OS perspective, for example, there's a CLI based install, which again is something you can script with MDM. I've just marked one comment as a question actually in chat, because I think it's worth mentioning. The general gist of it is that from a financial point of view, Leostream is an extra cost. You don't need it, but it gives extra functionality. Now, the distinction there is that NoMachine Enterprise Desktop as an application sits on the target device that sits in a lab. To provide access to that remotely, you need something that sits in the middle of the outside world and that desktop device. So you can use NoMachine Cloud Server, and that's been mentioned a couple of times, but that does carry its own cost. And the way it is costed is per, I think it's pack of 2 processor cores in the server. So there is an additional cost to that, and that also acts as a broker. The reason we've got, as I mentioned earlier, the reason we've got Leostream talking to you guys is, yes, there is an additional cost there, but it allows that outside world access. From an organization perspective, and this really depends entirely on how many devices you have that you want to access remotely, but say it's above 10 or 20. In a normal NoMachine environment, say you decide to put all of the students on a VPN and you give them all a copy of the free version of NoMachine, and you install NoMachine Enterprise Desktop on all of your lab machines. What that means is, provided the various discovery protocols and stuff are enabled on the network and can route via the VPN, the students would then fire up NoMachine on their device, and they would be able to see every single Mac that is in that estate, regardless of what it is or what it does. Now, that's not a very good student experience, because they won't necessarily know which machine to connect to remotely. They won't necessarily know what resource is available. And it doesn't give you a policy or a routing based environment to guide a student directly to the resource that they require. Now, the things that NoMachine Cloud Server does and Leostream does, and I'll add the asterisk there, Leostream does it with a GUI in a really, really easy way compared to NoMachine Cloud Server, which is all CLI and config file based. Is you can then group machines into those resource groups, as Karen showed you earlier. So there could be a lab of audio machines. There could be a lab of video-specific machines. You could have metadata and a pool of devices that have a specific piece of software on. You can group them in as many different groups as you need to. So you can have your Windows devices that go to ZCentral. You can have maybe architecture and CAD in one pool. You can have, if you've got PC-based video workstations in another pool, you might have machine learning in another pool. You might then have audio and video on the Mac side. You might have coding. You can then tag all of these devices as those different types of resource groups. And then when a student logs into the Leostream gateway or the broker interface, what they then see is only the groups that they're allowed to see, number one, and only the groups of devices, not every single device that's in the infrastructure. So while there is an additional cost, the benefit to the IT organization side of things and the student experience is absolutely huge. And it means you've got centralized management of a platform. It's kind of akin to the discussion of having a load of Mac estate and not having MDM, or having a load of Windows devices in your estate and not having SCCM or Intune or any of those technologies, and having Linux without Spacewalk, Rudder, or all of that kind of stuff. So there is a big argument for centralization. That being said, if you've only got a few devices and you're happy with just students being able to browse like 10 devices and just pick one, then that's absolutely fine. But certainly what we're finding in the majority of environments we're dealing with is that we're talking about labs, multiple of devices within multiple use cases, which is why we've got this kind of collection of products together. So hopefully that clears that up. I know it wasn't necessarily a question, but I thought it was a poignant point that was well made, that I thought it was worth addressing. So I think we've actually managed to get through all of the questions and keep to time. So as there is a delay, I'm going to carry on rambling for a few minutes. But if you have any more questions, please ask them now. Otherwise, we'll start wrapping up, and we'll hang around in chat afterwards for a little bit just to answer any straggling questions that there may be. So if nobody else has any more questions for us, I think that does it. I can't speak any slower than that. So thank you everybody for engaging. Thank you for being in here. This is probably one of the most active webinars we've had for a while in terms of the chat activity. So that's really awesome. Also thanks to Neil for being a silent co-moderator, as he called himself, and Jan as well for pitching in too. It's really great to see that interaction in almost like a community environment. So really, really awesome to see that. As you guys all know, you've got my personal email address as a result of the invites that went out. You've got Neil and Jan, as well as resources to reach out to. If you need any other information, if you want trial keys, if you want some help, you want some support, etc., please reach out to us and we'll absolutely help you there. One more question, I think, then, by the looks of it. So from what you said, you are saying both Leostream and Cloud Server give you the pool management, but Leostream has a GUI. Yep, and the pool management in Leostream is a lot more granular in terms of the control that you can provide to the machines than NoMachine Cloud Server is. So there's a lot on the Cloud Server roadmap, I know there is. But from a Leostream perspective, configuring a pool is literally a couple of buttons, and then you can either add machines automatically via the metadata that they contain, which is why the agent needs to be on them. So things like OS version, serial number, octets of a MAC address, parts of a host name, etc. All of that, all of that stuff can be used as ways to group devices. And because the Leostream agent will auto register with a broker once it's installed, which is again how you avoid DHCP issues, by the way, provided that it's reading the correct metadata, that machine is automatically added to that pool, which is something that NoMachine Cloud Server doesn't do. You have to manually add all of the enterprise desktop machines to Cloud Server, and then you need to group them together manually. And if you have DHCP, that can get really, really confusing because IP addresses change and things and leases run out, etc. So by using the Leostream agent, you avoid that dynamic issue because the machines effectively self-register. So I've just had a note saying I don't have your email. Okay, well, you guys should have had a reminder email for the webinar that should have been dispatched as my email address, but provided you promise not to spam me with support questions when you have them, but feel free absolutely to ask me questions. My email address is going in the chat right now. Check I've got that right. There you go. That is me. So any follow-ups, feel free to email me. What you may get, depending on what your question is, I may introduce you to one of my colleagues. There's a lot of people who know far more than I do about this stuff in our organization, but I'll absolutely either point you in the right direction, help you out myself, or engage in a bit of a workshop discussion. So I think that is it. What are the comparison costs per node between NoMachine and ZCentral clients and agents? That is a question that I would engage with Neil with after. So Neil, if you want to make sure the person that asked that question has your email address, or Matt or Jan as appropriate, that would be awesome. So on that note, I think we are going to wrap that up there. So I'm going to stay in the chat for a little bit. Karen and Matt, if you could just hang around as well, just in case there's any other questions that pop up. We'll give it a few minutes and then we'll close off. Other than that, thank you everybody for attending. Much appreciated.